Okay, first question. Resolution is the ability to distinguish two objects as separate. So I will stop for 5 seconds so you can think about your answer. So resolution is the ability to distinguish two objects as separate. That's correct. That's the definition of what resolution is. If when using the microscope, you are not able to distinguish two different areas in the slide, then you won't be able to see the details, right? So then basically resolution is the ability to distinguish two objects as separate. That would be the definition of what it is, right? So therefore this should be true. And that's what we have right there. Next question. When you place the slide on the stage, be sure and keep the cover slip facing down towards the light source. Okay, I will stop for 5 seconds. Okay, the cover slip actually goes on top of the slide, right? So then putting upside down is not necessarily correct. So then if we look at this figure, so this is the cover slip, and you can see how this is being placed on top of the slide. And obviously putting upside down, that's not correct. Then going back to the question, the answer should be false. And that's what we have right there. Okay, next question. Depth of field is reduced with increasing magnification. I'm going to stop so you can think about the answer. Okay, so depth of field is reduced with increasing magnification. Then this is just basically a concept. What happens is when you increase the magnification, the depth of field is reduced. How deep you can see is going to be less when you increase the magnification. The answer should be true. And there you go. Okay, next question. The typical magnification of the ocular lenses is... Okay, I will stop for 5 seconds so you can think about your answer. Okay, the ocular lens is the fixed lens, right? And that fixed lens is always 10, right? So if we look at this figure right here, so we have the ocular lenses, this one, and these lenses do not change, right? So this is going to be fixed, and this is always going to magnify the object 10 times. Remember, these ones right here are the objective lenses, and they are the ones that change, right? So then depending on which one you are using, the magnification is going to be different. Therefore, these ones are going to have different values. However, the ocular lenses are always going to be the same, and therefore this is going to be 10. Going back to the figure. Okay. Next question. The total magnification being used is calculated by adding the magnification of the ocular lens to that of the objective lens being used. Okay, I will stop for 5 seconds so you can think about your answer. Okay, it says in here that the total magnification is used by adding the magnification of the ocular lens and the objective lens, but that's not correct. We do not add, we actually multiply. If we go to the figure, we have right here the ocular lens, which is fixed, right? This is going to be 10 always. And we multiply that times one of the objective lenses, whatever is the objective lens that we are using, right? So let's say we are using this one right here. This one is, let's assume that this is 10. This lens is going to magnify the object 10 times. And this one right here is going to magnify the object 10 times. So therefore, the total magnification is going to be 100. 10 times 10. Okay, and that will give us the total magnification there. So if we go back to the question, then we can see that this is going to be false. And if you scroll down, right there is false.